Hello students. Hello and welcome to this video. In this video, we will solve question number 41 to 50. The link to download the PDF will be in description, as well as at the end I will show you how you can maintain an updated copy of the PDF. And I will show you my website where you can come and ask questions related to math. So first of all, there is a minor bit of correction. I have already written this in the description of the previous video. So when you multiply this 2 cos 2 raised to the power m theta with this, it should be 2 into 2 raised to the power m theta. Here a factor of 2 is missing, okay? And then you expand cos 2 theta is equal to 1 plus 2 cos square theta. So it becomes 2 cos 2 raised to the power m plus 1 theta, okay? So that's how we arrive at this, all right? Okay, so now we go ahead and do remainder of problems. The question 41 says that show that tan inverse x by 1 dot 2 plus x square plus tan inverse x divided by 2 dot 2 times 3 plus x square and so on up to tan inverse x over n times n plus 1 plus x square is equal to tan inverse x minus tan inverse x over n plus 1, where x is in the set of real numbers. So we let the given expression to be Pn as usual and substitute n is equal to 1. So n is equal to 1, what the first term becomes is tan inverse x over 1 dot 1 times 2 plus x square. This we can write as tan inverse x minus tan inverse x over 2, which is tan inverse 2x minus x by 2 plus x square, which is equal to our left hand side. So it is true for n is equal to 1. Let it be true for n is equal to m. So we have this expression, this full expression here, okay? And then what we do is we add the next term, tan inverse x over m plus 1 times m plus 2 plus x square to both sides. So obviously left hand side will represent the m plus 1, but right hand side becomes tan inverse x minus tan inverse x over m plus 1 plus the term we have added, that is tan inverse x over m plus 1 times m plus 2 plus x square. Now this new term is equivalent to tan inverse x over m plus 1 minus tan inverse x over m plus 2. And this x over m plus 1 will get cancelled with x over m plus 1 and we'll be left with tan inverse x minus tan inverse x over m plus 2. And thus by induction we have the result. Question 42 says that prove that 3 plus 33 plus possibly 333, yeah, indeed 333 and so on up to 333 with n digits is equal to 10 raised to the power n plus 1 minus 9n minus 10 over 27. So this question is an exact copy of this one, 16, okay? So we will solve it like 16. So we let this given expression is P of n. We substitute n is equal to 1. The first term is 3 and right hand side becomes 10 square minus 9 minus 19 by 27, which is 81 over 27, which is 3. So we see that it is true for n is equal to 1. We let it to be true for n is equal to m. So we have this expression here. And then we add 3, 3, 3, 3 up to m plus 1 digits to both sides. The left hand side will take the form of pm plus 1. Right hand side we add this, okay? So this m plus 1 can be written as 3 by 9 times 10 raised to the power m plus 1 minus 1, because it is essentially equivalent to multiplying and dividing by 3, okay? So multiply this by 3, it becomes 99999 m plus 1 digits. So this should be m plus 2, not m plus 1. This should be m plus 2. Once we have that, we solve and we get the end result as 10 raised to the power m plus 2 minus 9m plus 1 minus 10 by 27. So keep in mind that these are m plus 1 digits, so 999 will be m plus 1 digits. So if there is 9 to the power 1, then 10 minus 1. If there are two nines, then 10 square. So now this is fine, this is m plus 1. It won't be m plus 2 digits. I was wrong. Thus, we have proven by induction the result. For next two questions, you need to know calculus. If you don't know calculus, you can come back later and solve these problems. But if you know, let's see. So question 43 says that show that integration of sine 2n plus 1 x over sine x dx within limits 0 to pi is equal to pi. So we let the given expression be Tn. Now we put n is equal to 1. So we get sine 3x over sine x dx. This we can write as 3 sine x minus 4 sine cube x over sine x dx. This becomes 3 dx minus 4 sine square x dx. So 3x is the integration of dx, and 3 gets multiplied, that is 0 to pi minus 2, and we have 0 to pi 1 minus cos 2x dx. So then we will integrate 2x from 0 to pi plus sine 2x between 0 to pi after integrating cos 2x. So this will become 0, sine 2x will become 0 for both the limits, and this will become minus 2 pi, so it will be pi plus 0, which is true for n is equal to 1. Now let it be true for n is equal to m, so pm is equal to pi. Now we compute pm plus 1 minus pm, so we get sine 2m plus 3x minus sine 2n plus 1 x, it should be x, over sine x dx. To apply the formula, we get 2 cos 2m plus 2x sin x over sin x dx. This is equal to cos 2m plus 2x dx, which is equal to 0, which means pm plus 1 is equal to pm, which is pi. And thus by induction, we have the result. So here is a typing mistake, this should be x. Question 44 says that show that integration of sine square nx over sine square x dx between limits 0 to pi is equal to n pi. So we let given expressions to be Pn. So P1 is, we put n is equal to 1. P1 is integration from 0 to pi, the limit pi is missing here. Sine square x over sine square x dx, that is x from 0 to pi, so it is pi, so it is true for n is equal to 1. Will it be true for n is equal to m, so Pm is equal to m pi. Now again we compute Pm plus 1 minus Pm, we get sine square m plus 1 minus sine square mx over sine square x dx. So we integrate and solve, we get pi as the answer, and thus Pm plus 1 becomes m plus 1 into pi, and thus by induction we have the result. Question 45 says that show that tan inverse 1 over 1 plus 1 plus 1 square plus tan inverse 1 over 1 plus 2 square and so on up to tan inverse 1 by 1 over 1 plus n plus n square is equal to tan inverse n plus 1 minus pi by 4. So we let the given expression as Pn, and we put n is equal to 1. So we get tan inverse 1 over 1 plus 2, which is equal to tan inverse 2 minus tan inverse 1. That is tan inverse 2 minus pi by 4, or tan inverse 1 plus 1. Thus it is true for n is equal to 1. We let it be true for n is equal to 1. We have got this expression. Okay. Now we add tan inverse 1 over 1 plus n plus 1 plus n plus 1 whole square to both sides. Pm plus 1 on the left side will form, and right hand side will become tan inverse n plus 1 minus pi by 4 plus tan inverse 1 over 1 plus n plus 1 plus n plus 1 whole square. Now this expression, this new term which we have added, is equal to tan inverse n plus 2 minus tan inverse n plus 1. Tan inverse n plus 1 will get cancelled, and we will have tan inverse n plus 2, this should be 2 minus pi by 4. And with that, we have proven the result by induction. Question 46 says that show that if n belongs to the set of natural numbers, n times n plus 1 times n plus 5 is divisible by 6. We let P of n is equal to n times n plus 1 times n plus 5. We substitute n is equal to 1, we get P of 1 is equal to 1 into 2 into 6, which is divisible by 6. We let it be true for n is equal to m, that is m times m plus 1 times m plus 5, or m cube plus 6m square plus 5m is equal to 6k, where k is in the set of natural numbers. Now what we do is we compute Pm plus 1. So we put n is equal to m plus 1, we get m plus 1 times m plus 2 times m plus 6. We multiply that, we get 6k plus 3m square plus 15m plus 12, or 6k plus 3m plus 1 times m plus 4. Now clearly 3m plus 1 into m plus 4 is equal to 6q, where q is in the set of natural numbers. So how this is equal to 6q is that factor 3 is present. So we need a factor of 2. Now m plus 1, if it is odd, m plus 4 will be even. If m plus 1 is even, this will be odd. So one of these is even, so that will contain a factor of 2. So 3 into 2 will be 6, and the remaining things are natural numbers, so q will be natural number. And thus by induction we have proven the result. Question 47 says that show that if n belongs to natural numbers, n cube plus n plus 1 cube plus n plus 2 cube is divisible by 9. So proceeding like previous problem, we let Pn is equal to given expression, we put n is equal to 1, we get 1 cube plus 2 cube plus 3 cube, 36, which is divisible by 9. So it is true for n is equal to 1, we let it be true for n is equal to m. So we get m cube plus n plus 1 cube plus n plus 2 cube is equal to 9k. Now Pm plus 1 is m plus 1 cube plus m plus 2 cube plus m plus 3 cube. Now if you substitute this 9k over here, then it becomes 9k plus 9m square plus 27m plus 27, and we take out 9, we get k plus m square plus 3m plus 3. Hence by induction we have proven the result, because it is definitely divisible by 9. Question 48 says that show that if n is in the set of positive integers and n is even, when then n times n square plus 20 is divisible by 48. We let Pn is equal to n times n square plus 20, where n is even and also n is in the set of positive numbers. We compute, we put n is equal to 2, we get 2 times 24, that is 48. We let it be true for n is equal to 2m. So P2m is equal to 2m times 4m square plus 20, we take out 4, we get 8m times m square plus 5, which is equal to 48k, where k is in the set of positive integers. Now the question you would ask is, how is it 48k, right? So let's see. We put m is equal to 1, then it is definitely product of 6. This m square plus 5 will become 6. Okay. And if you put m is equal to 3, then this is 24, and this is 9 plus 5, 14. So an even number will come out and it will become 48. So what I think this step is basically too much. We could have proven that this is, we let it to be 48k. Okay. We don't need to let it, we have let it to be 48k. We are not saying that it is equal to 48k. We are assuming that it is 2 for n is equal to 2m. So now we compute 2m plus 2, p of 2m plus 2. So it gets 2m plus 2 times 4m square plus 8m plus 24. And then we expand this and substitute for 48k. And we get 8 times 48 plus 3m square plus 3m plus 6, which is equal to 24 times 16 plus m square plus m plus 2. Now all we have to do is we have to prove that m square plus m plus 2 is divisible by 2. So we let qm is equal to m square plus m plus 2. We put m is equal to 1, which is 4. So it is 2 for 2. Now we let m is equal to qt. So qt is equal to 2 square plus t plus 2 is equal to 2x, where x is in the set of positive integers, right? Now we compute qt plus 1, which is equal to 2x plus 2t plus 2, which is divisible by 2, and hence by mathematical induction we have the result. Question 49 says, show that if n is in the set of natural numbers, 4a to the power n minus 3n minus 1 is divisible by 9. So we let Pn is equal to given expression, P1 is equal to 4 minus 3 minus 1, which is 0, and divisible by 9. So we let n is equal to m. So we let 4 raised to the power m minus 3m minus 1 is equal to 9k, where k is in the set of natural numbers. Now pm plus 1 is 4 raised to the power m plus 1 minus 3 times m plus 1 minus 1 is equal to 4 times 4 raised to the power m minus 3m minus 4. So from here we substitute 4 raised to the power m is equal to 9k plus 3m plus 1. We substitute here and we get at the end 36k plus 9m, which is divisible by 9, and hence by induction we have proven the result. Question 50 says that show that if n is in the set of natural numbers 3 raised to the power 2n minus 1 is divisible by 8. So we let Pn is equal to given expression, we put n is equal to 1, we get 3 square minus 1, that is 8, which will be divisible by 8. Now we let it be true for n is equal to m, so 3 raised to the power 2m minus 1 is equal to 8k, where k is in the set of natural numbers. Now Pm plus 1, we substitute 3 to the power 2m is equal to 8k plus 1 in this, and we get 72k plus 8, which is divisible by 8, hence by induction it is proven. So with this we come to the end of fifth set of problems on mathematical induction, and this is my website astrowork.org. You can click link 2, 3 and 4 to download Algebra, Trigonometry and Coordinate Geometry book. Note that these links will not contain the date, so you need to add the date manually, the original date from the website, so that you can maintain a copy. Every 15-30 days you can come back and check if a new version of the book has been released. If so, you can download and put the date again. I cannot put the date because if I do that, all the YouTube previous links will become invalid when a new date will come, and then updating all the links is simply not feasible. Second problem is that if someone shares the link, then that link will become invalid. Now, if you want to ask questions, you can come to this, click this 8th link, come to my website, kundika.astrowork.org. It is a question answer forum which I have created for you, because YouTube is not suitable for mathematical or programming questions. So this website will host all the questions, and you can come ahead, come log in, make a login here and ask questions. So with this, we end this video here, and in the next video, we will solve question number 51 to 60. Okay. So to remind you, there was a minor bit of correction here in question 40. This would be 2 times 2 raised to the power m here. Okay. And then we will have the result. So thanks a lot for watching the video. I hope that you are finding the video useful and informative. So if you have not watched the previous video in the playlist, you are new to the channel, go ahead and explore the channel. There are lots of videos for you. So watch as you need and as per your convenience. So thanks a lot for watching the video, and I'll see you in the next one tomorrow with 10 more problems. Have a great day and enjoy.